All right, everybody. So we're going to talk about calculating percent mass change as part of your lab. So let's see what we would have here. Let's start by, I'm going to make up some numbers here. So let's say you have your before and your after, the masses of your eggs, okay? And let's say we have the egg in the 100 gram per liter solution. And let's say we have the egg in another one, like the 200 grams per liter solution. So let's say that this one here weighed 30 grams, okay, before. And let's say it gained 10 grams. Oops, so let's say after it weighed 40 grams, okay? Let's say this one, the egg that was in this solution in the 200 was, let's say 80 grams, okay? And let's say it gained 15. So it went up to 95 grams total, okay? So if we graphed this, okay, or so let's calculate our difference, okay? So this is the change. Let's do this first. Let's calculate the change. So this one changed by 10 grams, and this one changed by 15 grams. So let's say if we graphed this here, okay, this is gonna be 10. So this is change in mass in grams, and down here is the different solutions: 100 grams per liter solution, 200 grams per liter solution. These are the solutions we put the eggs in, and then this one is up to 15. Let's say 5, 10, 15. Okay, so what this looks like right now, it shows that the 100 gram per liter solution gained 10, and the 200 gram per liter solution gained 15. So it makes it look like the higher you go, the more with the more concentrated sucrose solution you have, the more water is going to go into the egg, right? Because the water going into the egg is what makes the egg gain mass. So that's what this would make it look like. But if we just graph absolute mass change, like how much it increases, that doesn't show the real story, okay? Because if we think about this, remember that 100 grams per liter is more hypotonic, right? It is hypotonic compared to 200. So hypotonic meaning a higher water concentration. So technically, really, what we should see theoretically is more as this one going into the egg more than this one. But that's not what we're seeing based on this graph. So if we do percent mass change, if we graph this is going to give us a more accurate picture, hopefully, of our results, because it takes into account the initial mass of the eggs as well. So let's say that at first we had, this 30 grams, okay, and it goes to 40. So that's a 10 gram difference, right? So we have 10 grams. And so this is how we calculate mass change. So you're going to take 10, which is the difference, and you're going to divide 10 by the initial, which is 30 grams. And you're going to multiply this all by 100, because that gives you a decimal, and then you multiply by 100. And that is going to equal, what does this equal? Let me calculate this real quick. This is going to equal 33%. Sorry, I was having a brain fart. And so that's quite a big change. And so if we go from 80 grams to 85 grams, to 95 grams, okay, that is going to be this math right here. So we have 15 gram change, be the difference, and then we're going to put 80 here, 80 grams, and we multiply this all by 100, and that is going to be around 19%. Okay, so this shows the more true story, right? So it turns out that the egg in the 100-gram solution actually did grow more than this one as far as a percentage goes, right? So if we graphed this now, this would show a more accurate picture. So here's the 100-gram solution, here's the 200, and we would have a bar here that is slightly higher than this bar, which makes sense because we're saying this is how much water was gained by, or how much mass was gained by the egg through osmosis due to water, okay? So this kind of paints a more accurate picture, all right? So this is how you calculate it, right? So this is if you could follow along with that. So I'll just write it one more time here in the corner. So we have the change in mass divided by the initial mass, the before mass, and then you multiply that times 100, and that is how you get the percent change in mass. So this is what you're going to write down in that data table, okay? And then you will graph that, okay? Thank you. Let me know if you guys have any questions. Bye.